Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at how to find the magnitude and the direction of a vector. So let's go ahead and get started. So here on this page, we have a picture of a vector, and if I had to try to make this as simple and clear as possible, because this is review, A is the initial point at 0, 0, B is the terminal point at 3, 5, and this is of course in standard position here because the initial point is 0, 0. Now, when we're talking about the magnitude, what we're trying to do is we're trying to figure out what is this distance from A to B. This right here from A to B, this is our magnitude. And we want to figure what this, how far this is. And of course, you could probably tell that, Pythagorean theorem would be a great tool for this. And we're going to talk about more about that in a second. Now, another thing that we're going to talk about also is the direction. In other words, which way is the vector going? Is it going this way or that way or this way? And of course, this brings in ideals from the unit circle, and we're going to be using the tangent and the arctangent for that. So let's take a look going back to magnitude. So to explain magnitude is very, very simple here. I have a vector, I have a vector v, that's what I can call it, and it has, oh, that's really ugly. It has the terminal points of A, B, like so. All right. Now, to find the actual magnitude, like I already mentioned a few moments ago, is you just take a vector v, this is another way to write it, and it's going to be basically a squared plus b squared, right here as such. Now, for the direction, which is something we talked about a moment ago, the direction, the formula for that is as follows. You have tangent of theta, and then it's going to equal b over a. So in this case, it would be the difference between the 2 points there for b, and then this is going to have to be converted because you're not quite done yet. You get this little double arrow here in many textbooks, and it's going to be theta, and then you're going to get equals again, and you're going to get arctangent, of b over a, and that'll give you the answer in degrees, which is what we want. So we've talked about this theoretically. Let's look at a practical example and see if we can make this work. All right, so here is our first guy right here. And so we have an initial point of negative 8, 1. So just to make this nice and clear, I'm just going to write this for you. So the initial point here is going to be negative 8, 1. Whoa. Terminal point is going to be at, let's see here, negative 2, negative 5, yes. So that's going to be our B. This is our A, actually. So this is our B. And so it's going to be negative 2, negative 5, like so. And so we need to find the magnitude and the direction. So the first thing we have to do now is that we have to put this in standard position. In other words, where the initial point starts at 0, 0. And so we've done this before in a prior video, but just to work it out in front of you, let me see if I can make it clear for you. So we're just going to call it like, a vector v or something. Vector v is going to equal the following. Still having a hard time with that. So we got negative 2, comma, minus negative 8, comma, and then we're going to have a comma right there. And then we're going to have a negative 5 minus a 1. Okay, so when we go through all this, there should not be a comma right here. Excuse me. So negative 2 minus negative 8 is going to be positive 6. So if I had to write my answer here, positive 6. And negative 5 minus 1 is going to be negative 6. So that is our that is our standard position here. It's going to be at 6, comma, negative 6. Now we can use this information. Now that we're in a standard position, we can use this information to find the magnitude and the direction. So let's first address the magnitude. So for the magnitude, because whenever you put this absolute value sign, it means magnitude basically. It's going to equal 6 squared plus 6 squared, and so that's going to equal square root of 72. And so if I want to simplify that, it would be the square root of 36 times the square root of 2. And so the final answer would be 6 times the square root of 2. So this distance right here is 6 times the square root of 2. You can confirm that yourself. Now, the last thing that we want to do, and we want to find the direction. And so this is where it gets a little bit, not trickier, but you have to take a slightly different approach here. So let me just block off some area here for myself, like so. Now, tangent of theta is going to equal b over a. So b in this case is negative 6. Negative 6 over 6. And so we know that that's going to equal negative 1 because negative 6 over 6 is negative 1. Now we have to find the arctangent of that, because to find tangent we have to do the opposite of which is arctangent, the inverse, if you will. And so if you do that, you're going to have tangent of, let's see here, of to the negative 1 power times, or excuse me, negative 1. And that is going to give you a theta of minus 45. You can, of course, confirm this if you look at the calculator here. And so I got arctan, and then I put in, negative 1, like so, and I get the negative 45. All right, so now we have to figure out, well, where is negative 45? Well, this is where it gets kind of tricky, because we know that it has to be in the fourth quadrant because the y value is negative here. So we know it's going to be, this is the y value essentially, it has to be a negative. So essentially we have to add 360 degrees to it in order to make this happen. That's what we need to do in order to have success in this particular situation. So we take negative 45 plus 360 degrees because we have to be in the fourth quadrant, and then we get the answer of 315 degrees. That's the answer here in comparison to the unit circle. And so if you look here on the on this new slide, the black line represents the original vector that we had, the a to b. Where it's at negative 8, 1 and negative 2, negative 5. The brown line is when it's in standard position, and so we know that the distance here is 6 times the square root of 2, and we know that the angle here, or the direction of it, is 315 degrees, which again, this makes sense for the unit circle. If you drew out the unit circle around this, if you will, as to give you an idea of what's going on here. And so that is essentially how you find the magnitude and the direction for a vector. So let me go back and review what we talked about and then conclude the video. So in this video, we looked at how to find the magnitude and the direction of a vector. And so essentially the magnitude is the distance from the initial point to the terminal point of a vector. That's obvious. And so to find that actual answer, you first have to make sure that your vector is in standard position, and then to find the magnitude, which is what these little bars here represent here, these two bars, you basically use the Pythagorean theorem in many ways. So a squared plus b squared is going to equal c squared, but then you have to do the square root of it. Now, to find the actual direction involves using the tangent function here. Tangent theta equals b over a, or you could say y over x. And then, you have to find the arctangent, or the inverse function of the tangent, to get it in degrees. And so then we had our example here, and we've had an initial point of negative 8, 1, and a terminal point of negative 2, negative 5. And so we first, in this part right here, we converted it to standard position. So, x2 minus x1, y2 minus y1, etc. And we got 6 comma negative 6. This is our vector right here. And so then from there, we were able to calculate the magnitude, which was basically the square root of 6 squared plus the square root of 6 squared. And we found out that that equals 6 times the square root of 2. So the distance from A to B is 6 times the square root of 2. Now, to calculate the actual direction, we had to take the negative 6, that's like kind of our y value, if you will, over 6, and we got negative 1. And then we used the inverse tangent for our arctangent, the inverse function of tangent, or the arctangent, to find what theta is in degrees, and it was negative 45. Now, we know that this has to be in the fourth quadrant because of the behavior of the actual y value, which is negative 6. And so it would be, over here, like I showed you. Whoa. It would be over here, like I showed you, down here, over here. And so in comparison to the unit circle, we know that these values are going to be almost close to 360. So to find that final answer, we had to take negative 45 plus 360, and we got 315, and that gave us positive 315 degrees, and that was how we were able to indicate what was the actual direction of the vector. And so this is how all the different parts that we've learned so far are working together to help us to understand what is happening here with vectors. So I hope that this video was useful for you, that you were able to understand what we talked about and that things were clear. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.